Hello again. Today is the July 1st, 2026. Today I'm going to go over the definitions so I don't have to look at them more and I can just listen to them on the phone or wherever. And so let's begin. Define combinations. Combinations are essentially defined as permutations where the order in which the elements appear does not matter. The order does not matter. The order does not matter. That's very important. Going back to the early example of the set 1, 2, 3, the possible combinations that can be made from the set are 1, 2, 3, 12, 13, 23, and 123. Next, explain how to find the number of combinations in a set of elements. In a set containing n elements, the number of combinations of R items from the set can be found using the formula n capital C R equals in the numerator n factorial, leaving the numerator, going past the verticulum into the denominator R factorial parentheses n minus r end of parentheses factorial. Notice the similarity to the formula for permutations. In effect, you are dividing the number of permutations by r factorial to get the number of combinations, and the formula may be written as NCR equals in the numerator n capital P R all over R factorial. When finding the number of combinations, it is important to remember that the elements in the set must be unique. There must be one of them. No duplicates, i.e., there must not be any duplicates. And that no item may be used more than once in any given sequence. Going to, that was not the right one. Alright. Explain probability and probability measure. Probability is the likelihood if a certain outcome occurs for a given event. An outcome is a situation that produces a result. It could be something as simple as flipping a coin or as complex as launching a rocket. Determining the probability of an outcome for an event can be equally simple or complex. As such, there are simple, specific terms used in the study of probability that need to be understood. Compound events, desired outcomes, independent events, dependent events, certain outcomes, impossible outcomes, mutually exclusive outcomes, and random variable. Starting with the compound events. Events that involve two or more independent events, like rolling a pair of dice and taking the sum. Desired outcomes. For success. An outcome that meets a particular set of criteria, a roll of 1 or 2 if we are looking for numbers less than 3. Independent events. Two or more events whose outcomes do not affect one another. Example, 2 tossed coins tossed at the same time. Next definition. Dependent events. Two or more events whose outcome affect one another. 2 cards drawn consecutively from the same deck of 52 cards. So it would be 52, then 51. Certain outcomes. Probability of outcome is 100% or 1. Example, death or consequences. Change as well. Impossible outcomes. Probability of outcomes is 0% or 0. Like me getting $100 billion tonight. Not gonna happen, but I can dream. Mutually exclusive outcomes. Two or more outcomes whose criteria cannot all be satisfied in a single event. A coin coming up heads and tails on the same toss. You can't do that. Random variable refers to all possible outcomes of a single event which may be discrete or continuous. Discrete is finite and continuous is infinity. Define sample space and outcome. The total set of all possible results of a test or experiments is called sample space, or something a universal sample spaces. The sample space is represented by one of the variables S, amp symbol, the omega, or capital U for universal sample spaces, has individual elements called outcomes. Other terms for outcomes that may be used interchangeably include elementary outcomes, simple events, or simple point, or the result. The number of outcomes in a given sample space could be infinite or finite, and some tests may yield multiple unique sample sets. For example, a test conducted by drawing playing cards from a standard deck would have one sample space of the card value, another sample space of suit denominator combinations. For most tests, the sample space considered will be finite. Going to the next stuff. Explain the complement of an event. It is basically the negation of an event. Sometimes it may be easier to calculate the possible outcome possible of something not happening or the complement of an event. Representative by the symbol A. Complement. The A has a hat. The complement of A is the probability of event A occurring. You can use the formula PA complement equals 1 minus A complement, where P complement is the probability of event not occurring and PA is the probability of an event occurring. Again, complement is just negation. Page 81 in my notebook. Define events, page A5. So simple definitions that I went over again earlier, not in this video, but another one. But I'm gonna go over it again because what is it called? Practice makes permanent. Yeah, practice makes permanent. Explain how to find the factorial of a number. The factorial is a function that can be performed on any non-negative integer. Factorial of an integer is the product of all positive integers less than or equal to the number. Define permutation. Order matters. For any given set of data, the individual element in the set may be arranged in different groups containing a different number of elements arranged in different orders. The order matters. Order very much matters. Explain how to find the number of permutations of a given set. To find the number of permutations of R items from a set of N items, use the formula N capital P R equals in the numerator N factorial going south from the numerator into the denominator, passing the verticillum. Start a parentheses N minus R parentheses factorial. When using this formula, each element of R must be unique. There must be one of it. It must be odd. Explain how to find all possible permutations of a set of unique items. To find the number of possible permutations of any number of elements in a set of unique elements, you must apply the permutation formulas multiple times. Yes, multiple times, like a factorial, but like going down. Interesting. Define combinations. Combinations are essentially defined as permutations where the order in which the elements appear does not matter. Permutations, order matters. Combinations, order does not matter. Which I would like to think of POCO. PO is order matters for permutations, and the CO means order for combinations doesn't matter, and POCO in Spanish means kind of. Going to the top. Because practice makes permanent. Explain how to find the factorial of a number. The factorial is a function that can be performed on any non-negative number. Integer, sorry. It is represented by the exclamation mark sign, written after the integer or on which it is being performed. The factorial of an integer is the product of all positive integers less than or equal to that number. For example, 4 factorial is calculated as 4 times 3 times 2 times 1 equals 24. Since 0 is not itself a positive integer, it does not have any positive integers less than it. 0 factorial cannot be calculated using a method. Instead, 0 factorial is defined by the convenience or something is to equal 1. This makes sense if you consider a pattern of descending factorials. 5 factorial equals 120. 4 factorial equals 24. 3 factorial equals 6. 2 factorial equals 2. 1 factorial equals 1. And 0 factorial equals 1. Because 0 factorial divided by 1 equals 1 over 1 equals 1. I realized I did this with like the Pop Goes the Weasel thing. Did not work. Anyway, but you can do Pop Goes the Weasel with the quadratic formula. Note, you can see this reasoning with exponents too. What I mean is when a number is to the power of 0, it is equal to 1. Yes, it is. Darkness. My dog is looking. Yep. Define permutation. Order matters. For any given set of data, the different elements in the set may be arranged in different groups containing different numbers of elements arranged in different orders. For example, given the set of integers from 1 to 3, including the elements of a set of 1, 2, and 3, written as 1, 2, 3, they may be arranged as follows: 1, 2, 3, 12, 21, 13, 31, 23, 32, 123, 132, 213, 231, 312, 321. These ordered sequences of elements from the given set of data are called permutations. No way. Really? Permutations? Yes way. It is important to note that in permutations, the order of the elements in the sequence is important. The sequence 123 is not the same as the sequence of 213. Also, no element in the given set may be used more times as an element in a permutation than it appears. Complicated wording basically translated to there should only be one thing. If there's more than one thing, it's not unique. It needs to be unique. Further explains. As an element in the original sets, for example, 223 is not a permutation in the above example because the number 2 appears twice, one more than it should. Time in a given set. Page 67, no, in my notebook, and there's a badly drawn formula. Note before the end. Order is important for permutations. Explain how to find the number of permutations of a given set. To find the number of permutations of R items from a set of N items, use the formula NPR equals, in the numerator, n factorial all over the denominator of start parentheses n minus r end of parentheses factorial. Woo! When using the formula for each element of R must be unique. There must be one of it R. No more. No twos. It must be unique. Also, this assumes that the different arrangement of the same sets of elements yields different outcomes. For example, 123 is not the same as 321. Order is important. Order is important. Order is important. A special case arises while finding the number of possible permutations of n items from a set of n items. Because n equals r, the equation for the number of permutations becomes simply p equals n factorial. The same result is true for r equals n minus 1. Both of these cases are a result of the fact that 0 factorial and 1 factorial are both equal to 1. If a set contains one or more groups of indistinguibles or interchangeable elements, i.e., Ig, that the set 1, 2, 3, 3, which has a group of two indistinguibles, threes, there is a different formula finding the distinct permutations of all n elements. Use the formula p equals n factorial, which is in the numerator. We're going south to the denominator. m1 factorial, m2 factorial, mk factorial, comma, where p is the number of permutations. N is the total number of elements in the set, and m1 through mk are the number of identical elements in each group, e.g. for the set 1, 1, 2, 2, 2, 3, 3, m1 equals 2, m2 equals 3, and m3 equals 2. It is important to note that each repeated number is counted as its own element for the purpose of defining A, e.g. for the set 1, 1, 2, 2, 2, 2, 3, 3, n equals 7. Note 3. Page 71 in the notebook. Explain how to find all possible permutations of a set of unique items. Page 77. To find the number of possible permutations of any number of elements in a set of unique elements, you must apply the permutation formulas multiple times. For example, to find the number of possible permutations of a set 1, 2, 3, which has 3 elements, first apply the permutation formula for situations when n equals r as follows: p equals n factorial, which then equals 3 factorial equals 6. This gives the number of permutations of the 3 elements. When all 3 elements are used to find the number of permutations of the 3 elements, when all 3 elements are used to find the number of permutations. When only 2 of the 3 elements are used, use the formula NPR equals in the numerator n factorial, leaving the numerator to the denominator, n minus r factorial, where n is 3 tres and r is 2 dos. NPR equals in the numerator n factorial all over the denominator n minus r factorial equals 3p2 equals 3 factorial, which is in the numerator. We're going south to the denominator now. 3 minus 2 is 1 factorial. All translates to 6 all over 1 equals, simplified, 2, 6. Woo! To find the number of permutations when one element's used, use the formula NPR equals in the numerator n factorial all over the denominator n minus r factorial when n is 3 and r is 1. Uno! NPR equals in the numerator n factorial all over the denominator n minus r factorial. This goes to 3p1 equals 3 factorial in the numerator all over the denominator 3 minus 1, which equals 2 dos factorial. And simplified more, 3 factorial all over 2 factorial equals 6 over 2, which simplifies to 3. Find the sum of the three formulas. 6 plus 6 is 12. 12 plus 3 is 15. Total possible permutations can be written as followed. Summary. Summation. Weird big E thing. N. I equals 1. N factorial all over I minus 1 factorial. Woo! Page 77. We came back to combinations. Woo! So the things we did was how to find the factorial, explain how to find, I forget what, define permutation, order matters, combination, order does not matter. And a lot more other things. Have fun.